So goodbye. Thanks. Okay, so yeah, that is all about me. Maybe if you wonder, my hobbies are playing games, reading books, having a chat with my friends, all these stuffs. And I really are doing mathematics. Right now, I'm a fourth year graduate student at Michigan State. My major is mathematics, and I'm focusing on partial differential equation, which is very similar to this kind of stuff, proving the existence of solutions. Solution is nice and beautiful. It explains some meaning for the solutions in physics phenomena or something like that. So that is my major. And I have taught MTX 233, 234, and 235 a couple of times. This is my second time. Yeah, okay. And also 299 is about logic and math. Okay, so that's all. So let's jump to the lesson. So what do we study today? So today we're gonna recall some definition about separable equations. What does it mean by separable equations? What does it mean by Euler homogeneous equations? Okay. So first, let me call what is the differential equation. So if you have an equation like y prime, so you can call the time, okay, equal to a function which depends on t and yt. So we call the differential equations. So in here, you can call t is independent variable. So you can call y is dependent variable. Okay. So yeah, so as long as you can write the right-hand side in terms of a function depends on f. If it's a function, so then you can call the differential equations. So you have two sides, left-hand side, y prime, right-hand side. So function depends on t and y. Okay. For example, I can give you a bunch of examples. Let's say example one, the easiest one is the trivial case, like f is a constant function, right? It's the critical case. Y prime equal to 0. So you can see here like this, right? So what does it mean? It means that the rate of change is 0, it's never change. And if you solve for it, it's just a constant. Okay, it will not change with time. The second example is a trivial one, for example, like y. Okay, so that means f ty, okay, equal to y, right? So there is no t variable of the function f. So we can have that kind of example, right? So if you solve for that equation, you're gonna get t equal to exponential of t time with some initial condition. Okay, a more complicated one, you can come up with y prime equal to so let's say t square plus y square, and maybe some complicated stuff like minus cosine of ty exponential of y. Okay, something like that. So you can see we have a bunch of differential equations. It can be nonlinear, it can be linear, and we have different names for it. And this one in particular is just the first order. Why do we call it first order? Because we take derivatives one time. Okay, so if you have y double prime or take the second derivative, so you can see the second differential equation. And yeah, the four differential equation means that you take the differential, differentiate the y in 4 times, and etc. Okay, so one of the basic questions that you may come up with is how do we solve that kind of equations? So in general, we don't have a general formula to solve for that differential equation. we should know that the solution exists locally, meaning that we can use mathematical proof to show that solution exists locally. It's not globally, but it's locally. And we can even estimate the maximal time existence, but that is a mathematical story behind this. We don't study this anyway. So that is about the differential equations. So what does it mean by separable equations? Okay, so from here you can kind of guess what it is, right? You can separate it into, so we have independent variable, we have dependent variable. If we can separate it by multiplication, so that means it's a separable equation. So what exactly is that? If you have a formal definition for that is we have a function h depends only on y, independent variable, and you multiply by y prime equal to some function depends on t, right? So as you can see here, you can separate this part and this part, right? This part will not depend, does not depend on y, on t, and this part does not depend on y. So we call the separable equation. Okay, and the way for you to solve it is just take the antiderivative of the integral both sides like this, right? And after doing that, you have some hint, right? If you are able to compute this, maybe you cannot, some function you cannot, for example, sine of t divided by t, you cannot find the antiderivative of that function, so you just keep it. Okay, some function you can, some function you cannot. And for but similarly for this term is the same scenario. Sometimes you can, sometimes you cannot. If you can, so that's a good story. So yeah, you can solve it, and if you cannot, just let the solution be like that. Okay, so if this one, when you do the integral, you remember you use the change of variable, right? So you can say like h of y prime equal to the integral of h of y dy. Okay, so if the function h is simple and easy to calculate, like a polynomial, exponential function, logarithmic function, rational functions, cosine, trigonometry functions, some kind of basic function, the combination of these tools is allowable. It's easy to compute, but some difficult equation, difficult functions, so maybe you are not able to compute the integral. Okay, but don't worry, you just need to do simple one to get the idea, understand it, and somehow solve it. And maybe in the future you can use that to maybe use calculator, computer, to Python, MATLAB, or whatever to code. It's very easy to calculate the integral by using computer. Then maybe you are able to solve that kind of differential equation. And solving differential equation is very useful in real life application. You can use it in prediction of stock model about weather forecast, or many phenomena like COVID-19, how many corona cases without vaccine, with vaccine populations. We use computer for it. So don't worry if you cannot calculate integral. Okay, so let me give you an example that is very easy and illustrate what is the separable equation. So I have the example like this: negative y prime divided by y squared times cosine of 2t. Okay, so so this is the separable equation. Why? Because I can separate this part, right? So function h here, hy here is just negative 1 over y squared, and function gt here is just cosine of 2t. So that is separable, right? Because it satisfies the definition, the formal definition for the separable equations. And so how do we solve for that kind of equations? So I'll let you think about it for maybe 3 minutes, and then I'll solve for you guys. If you get the solution, just type it in the chatting section, or you can say it out loud. You are welcome to do that. If you are not, this totally fine too. Okay, so now it's 10:35. I'll show it in 10:38. Okay, good. Okay, so I hope you done. You get the solution, or somehow you get the way to do it and know how to do it. Okay, so what do we do now? First, we will take the integral both sides y prime over 4 squared equal to integral of cosine 2t. Okay, so so to be careful, if you want, you can take the dt here, dt here. Okay, so we take the integral which against the independent variable, which is 5. Okay. And if you can, so what is it? On the left hand side, just the integral by part, or you can change the variable, so whatever is it. Get what is it? That one equal to, so y prime dt it actually equals dy, right? And divided by y squared. Negative side equal to the integral of cosine of 2t dt. Okay, so now if you know how to do calculus 1, I remember, do the integration, you are able to solve for this integral. So this is y squared, so which is y to the negative, the power. Try to write it carefully so then you are not confused. Okay, so this is just what? The polynomial, right? You take the integral of a polynomial of the nth order. In this case, it's equal to -2. So it's going to be -2, right? Or maybe I write here. Okay. Y to the -2 plus 1 divided by -2 plus 1 and negative sign, right? And equal to integral of cosine, right? So when you don't remember, you can remember like sine, you take derivative, it becomes cosine, and cosine take derivative, it becomes negative sine, and then the sine derivative become cosine like this. Sine derivative become cosine, and cosine derivative become negative sine. So that you can imply the integral, right? Imply antiderivative. So antiderivative of cosine is negative sine. So that is the way that you can remember easily. Remember to do the chain rule also. So it becomes -2 of sine of 2t. Sorry, cosine, the 2 sine of 2t. Okay, and then plus some constant. So it's when you simplify it, it's just negative and negative is positive. So nothing here, equal to 2 sines of 2t and plus some constant. And then okay, so from here you can if you refer to write down implicitly, so it's become phi per sine of ty, what equal to y to the -1 minus 2 sines of 2t. Okay, so that the implicit formula. Right. So if you want to solve explicitly, you can write that this y equal to 1 over. Oh, okay. I'm sorry, you're right. Okay, my bad. Thank you very much for your help. That is a good job. Okay. Yeah, you're right. Thank you for the chatting. He remind me that it should be 1/2 instead of 2. Very good. So y here, just take the 1 over c plus 1/2 of sine of 2t, right? But pay attention that if c is between -1/2 and 1/2, so it can make this one become 0, right? And it doesn't make any sense. So you will have a lot of asymptotes, like asymptote, vertical asymptotes, that kind of behavior if you write it down explicitly. So this is explicit formula, but be careful with that. Okay. So if the constant c is bigger than -1/2, so then or bigger than 1/2, sorry, c bigger than 1/2 or less than -1/2. So we don't have to worry about that because sine of 2t is between -1 and 1. So 1/2 of sine of 2t between -1/2 and 1/2. So if c beyond that interval, right, does not belong to that interval. So we don't have to worry. If c belongs to that interval, we have to worry. Okay, so that, and c is actually the initial condition for the equation. Okay, so that is for the first example about the separable equation. So now we have a bunch of practice problems. So let's try to do this together. So my rule is that you should practice by yourself first. Try to do it for 3 or 2 minutes. Maybe you cannot do it. Maybe you can. You can. It's good. You cannot, just learn for it. So yeah. So we have 3 minutes for each questions. So it's totally 9 minutes. After 3 minutes, I'm gonna solve for the first one, and then after another 3, I'm gonna solve for the second one and the last one. Okay, try to work on it. If you refer to work in groups of maybe 2 or 3 people, I can do the breakout room for you guys. Maybe next time, if you refer to stay here and just do it to save time, just go ahead and do it now. Okay. Okay, so I hope you get the solution for the first one, which is the easiest one and straightforward. And Euler is one of the first mathematician who come up with this equation. So it's still very simple, right? What does it mean by that? Y prime equal to y. So it means that the position equal to the velocity. Y prime represent for the velocity. Yeah, so that is very cool. He had the discovered exponential function, and he knows how to do the Taylor formula for that. So it's a very beautiful story. But nowadays it's become trivial. Y prime equal to y, and we have the y0 equal to 1. And how do we solve for that kind of equation? The first thing first, you can divide it, you remove everything. So in order to be, so this is very technical issues, just very easy to think of. I would like to express for you. So this is a dependent variable, right? Dependent variable. So if you want to solve for the separable equation, you move the all of dependent variable on the left hand side and keep the independent variable on the right hand side, and then you take the integral. That's just that simple. And so then you move y, you divide it by y equal to 1, and then just take the integral both sides like this, right? 1 or maybe dt, okay. And you know that it's become dy y equal to 1 dt, and then it's just the ln of y, right? Absolute value of y, and okay, equal to t plus some constant. Okay, again, so this is the, so if you find the explicit formula, so it's gonna be like this: ln of absolute value of y minus t. Okay, so this is implicit. Right, so how about the explicit formula? So the explicit formula, you take input exponential both sides, right? So you know that the natural log is an inverse function of exponential function, and vice versa. Exponential function is an inverse function of natural log. So in order to get to the natural log, you take the exponential function, so y equal to exponential. Remember that exponential is always positive, so absolute value is just vanished. You don't need that anymore. T plus c, right? And exponential t plus c is just by power rule, it's equal to exponential t times c, and it's just some constant times exponential t, right? So that is what we have. And also remember that, so okay, from here you have to be careful because you have the absolute value. Sorry, okay, from here you can see, from here, because c here, c prime here equal to e to the c, right? So it can be any arbitrary constant which is positive because exponential is positive. And so from here you separate it into two parts, either y equal to c prime e to the t, and or negative y e to the t, right? So then you can see that y can be any arbitrary constant times e to the t. So that is all of the solutions for y prime equal to y. And now we have to check the initial condition, right? Because to fix the initial condition, we fix 1 point. We know that y0 equal to 1, right? So you can see the function depends on t. So you can see that y0 equal to 1, that implies, so you plug in on the left, you have 1, on the right, you have c times e to the 0, and e to the 0 is 1, so then c is just 1. Okay, so now there you go. So then your solution is simply just y prime, yt equal to exponential t. Okay. So that is the solution for the first one. I don't have much space left. Okay, so let's do for the second one, and again you have 3 minutes. do for the second one. Okay, maybe I will introduce for you, give you a hint before doing the second one. The hint for the second one, we call the partial fraction. So it's a technique developed in, I don't remember, but 13th century, 14th century, something like that. It's been a long time, and Newton used it a lot. So what is it? So basically, you want to integrate some kind of rational function, like for example, like maybe y minus 1 times y plus 1, right? So something like that, and you don't know how to do it. You can use maybe you can use the partial fraction, right? So this is a fraction, and it's the second order only. So denominator is the second polynomial or the quadratic polynomial, and we want to make it easier because we know how to calculate for the fraction constant here, and on the bottom denominator is just the linear function 3y plus 6, right? So you can easily compute that because it's become log of 3y plus 6 divided by 3, right? So we plus some constant, okay. So we know how to do for the first order. We don't know how to do for the second order or the third order. So the idea is to transform the denominator on the second order into the, you have to pay for something, right? You get it's simple, so you have to have more. So you can transform that into two terms. One term is something y minus 1, and another term is b times y plus 1, right? And if we guarantee a and b exist, then we're done because we take the integral here. That one is so simple, that one is so simple, okay? So that is the idea of partial fraction. And how do we do with that? So actually it's very easy. For example, let me illustrate you with an example. For example, you want to do this y plus 1, y minus 1. You want to separate into two fractions like this. Okay, so many, there are many ways. Okay, many ways. But one of the ways that I like most is that I use the system of linear equations. I can consider a and b are unknown variables. I need to find a and b. Right? I know it's true for all y, right? Because it's true for all y. So I'm allowed to choose any y that I want, which is make the function make sense, right? Make sure that we don't divide by a zero number, right? So y has to be different from 1 and negative 1. So we cannot choose y equal to 1 and negative 1, right? But we can choose y equal to 0, we can choose y equal to 2, y equal to 3, etc. So let's see. I choose y equal to 0. So let's see what's happening. So I have 1 over 0 minus 1 times 0 plus 1 equals a divided by 0 minus 1 plus b to the 0 plus 1. Right? So what do I have on the left? Negative 1. On the right, negative a plus b. Right? So I have one equations. I just need another one to get the solutions for a and b. So I just do y equal to 2, let's say. So what do I have? I have 2 minus 1, 2 plus 1 equal a divided by 2 minus 1 plus b divided by 2 plus 1, right? What do I have on the left? It's 1/3. On the right, a plus 1/3 of b. Right, now there you go. You have two equations, two variables. Looks like it's independent, so then you can solve for a unique solution. Okay, 1/3 of b equal to 1/3. Okay, now there you go. That's it. That is the idea of partial fraction. So I don't write the formula. It's just not necessary. The important is that you get the idea how to do that. You just need to pick 2 points for y, and you solve for a and b. That's it. That is work for all of the fractions. Okay, so from here, if I want to solve, I just take the first one and the second one. So I have 4/3 of b equal to negative 2/3. and b equal to negative 1/2, and I plug in on the first one. I have negative a minus 1/2 equal to negative 1. So negative a equal to negative 1/2, and a equal to 1/2. So I have done. So 1 y minus 1 y plus 1 equals 1/2 y. What did I choose? Y minus 1 first, right? 1/2 y minus 1 and minus 1/2 y plus 1. Okay. If you want to verify whether my formula is correct, just have to do the common denominator. So it's just y plus 1 minus y plus 1, because minus is plus, and 2 y minus 1 y plus 1. So this is cancel out. 1 plus 1 is 2, cancel out. So it's become 1 over 1 minus 1 y plus 1. So I think this is the most the simplest approach that you can do the partition fraction. Okay, now go back to your practice problems. Let's see. Okay. Yeah, so do the second one and the third one is. You have 3 minutes for the second one and 3 minutes for the third one. After 3 minutes, I'll fix the second one, and then you have 2 minutes for the third one. And then fix the Okay, so I hope that you get the solutions. Okay, so let's fix the second one. We have dy over dt equals to y times y minus 1. Right? Okay, so again, let me remind you to move all the dependent variable to the left-hand side. You have y prime divided by y times y minus 1 equal to 1, right? And then you just take the integral both sides with respect to t, dt. Okay. And now you just use the integral backup or interchange variable. You have dy divided by y minus 1 equal to that 1 dt. And you can easily compute the integral on the right hand side because it's a constant. So it's t plus some constant. And now the problem is to compute the integral on the left hand side. It's a little bit complicated. It's a fraction. And this is denominator, as I said, it's a quadratic polynomial, and we just factorize it. So now we just need to do the partial fraction. So I want to integrate that means first I have to do the partial fraction. I want to have a y, right, plus b divided by y minus 1. And you know that we have to make sure that y is different from 0 and y is different from 1. Okay. Now I can choose, first I choose y equal to -1 to see what happened. And if you plug -1 on the left, you have 1 -1 times -2 is 2, right? F equal to -a and minus 2b, right? So I have the first equation. Very good. So now I choose y equal to 2. So what do I have on the left? 2 times 2 minus 1, which is 2 to 1/2. So 1/2 again equal to a divided by 2 plus b. Okay, it's beautiful. So now just write a minus 2b equal to 1/2 and a over 2 plus b equal to 1/2. And I just multiply this equation by 2 to get -a minus 2b equal to equal to 1/2, and a plus 2b equal to what is it? So 1, okay, and I add the first one. Okay, so now we have a problem for that. Okay, so what did I mess up? -1, -2, 1/2, a, -1, -2. Okay, so this is by b divided by 2. Sorry about that. Okay, b divided by 2. B divided by 2. Okay, so now I just take the first one plus the second one. I get 2b minus b hat, b over 2 is 3b over 2, right? Equal to 3 over 2, because 1 plus 1/2, so b equal to 1. Okay, b equal to 1, I plug in and I have a equal to -1, right? There you go. You have a and b. So in other words, you can write that fraction in terms of a and b. So it's going to be a negative ay, so it's going to be -1/2, 1y plus 1 over y minus 1, right? So that's it. Okay, so after doing this partial fraction, you should take the integral, right? So you take the integral both sides like this, and it's become dy, remember, dy y minus 1 become negative of log of y plus log of y minus 1. Okay, so then we plug in here, we have negative log of y plus log of y minus 1 equal to t plus c. Okay, and then if you want to find the solution, it can be it's explicit one. So it's gonna be fifth cosine of ty equal to log of y plus log of absolute value of y minus 1 minus t. So that is the implicit form. Right. Okay, so let me check whether we have the initial condition for this question. Okay, we do have the initial condition. We know that y0 is 4 and t is positive. Y0 is 4. Okay, so let me write here. The solution is log of y plus log of y minus 1. Okay, if you want to be careful, just plug in t here. T minus 1 equal to t plus some constant, and we know that y0 is 4. Okay, so you can either plug in t equal to 0 in this implicit form, or to find constant c, or you can solve easily by just manipulation, do the log rule. So log minus log is log divided by that, and then you take the exponential. You have something constant, and then you plug in y equal to 0, you get the implicit formula from the implicit formula. So in other words, we have two ways to solve for it. So let me pick the first way, y equals to 0. So let's see, negative log of 4 equals to log of 3, 0 plus c, right? So c equals negative log of 4. So it's going to be log of 3 over 4. Okay. So log of 3 over 4 equals to c. So the solution is just log of y plus log of absolute value of y minus 1 equal to t plus log of 3 over 4. So that is the implicit formula. And if you want to find explicitly, you can use the log rule. So it's going to be y minus 1 divided by y, absolute value here, plus t log of 3 over 4. Okay, and you take the exponential y. So it's just 1 minus 1 over y, absolute value. Exponential of that is going to be exponential of t, and exponential of log 3 over 4 is 3 over 4, right? So then you can solve for y. So y minus 1 equal to 3 over 4 e to the t. So you have 1 over y equal to 1 minus that, e to the t, and you have y is just the 1 over 1 minus 3 to the 4 e to the t. Okay, so now you can get the first solution, and if you plug in, this becomes y0, we check, right? This is t. Y0 is just 1 over 1 minus 3, 4. So it's going to be 1 over 1/4, which is 4. So it's satisfying the initial condition. Okay. So yeah, that's it. Right. Okay. So let's do for the question 3. Okay. So maybe we don't have time for question 3 because it's in the break time now. We have the break 10 minutes break from 11:10 to 11:20. So I'll be back in 8 minutes. It's now 11:12. Okay, see you in the next 8 minutes. Okay, it's time. We come back to question 3. Y prime equal t squared divided by 1 minus y squared. Y prime equal t squared divided by 1 minus y squared. And now you have to find the solution for this. Okay, again, just move everything, the dependent variable on the right to the left. So you multiply by 1 minus y squared, y prime equal to t squared. And next step is to take the integral both sides. To take integral both sides with respect to t dt. Okay. And now you can write it down again by independent variable like this and equal to t squared dt. Okay. And this integral is very easy to compute because on the left or on the right, either of them is just the quadratic polynomial. So it's just on the left, just y minus y cubed divided by 3 plus some constant. You can put the constant on the right. Don't worry. E cubed divided by 3 plus some constant. And now you have the solution ty implicit form negative y cubed divided by 3 plus y minus t cubed over 3. So implicit form here is always equal to the constant. Okay, let me double check whether we have the initial condition. We don't have, no, this not this. We don't have initial condition. So we don't know what is the constancy. It's just a family of solutions. It can be a bunch of solutions. All forms of solution can be written as this form. The sign of ty plus y minus t cubed plus equal to c. If you wonder how do we find the explicit form, is yes, we can, but it's very hard because you have to solve for a quadratic equation. It's not that easy. Okay, so that is a solution for implicit form. And we don't have to find for the explicit form because it's very hard to find a solution for the cubic function. We do have the general formula for it, but it's hard. Okay, okay, that is all about the separable equations. And now we go to the new definition and new section. Yeah. Okay. So so next stuff is about the Euler homogeneous equations. So what is the formal definition for the Euler homogeneous equations? Back to the idea that when we want to solve for first order equation, right? The differential equation, and it's hard. We know that separable equation is a good way to deal with that. Maybe some equation is separable, some equation is not separable. And the idea is to transform on a not separable equation to a separable equation. Okay, so that one of the way is Euler homogeneous equations. In that way, we are able to transform a non-separable equation into a separable equation. And he found out that if any first order differential equation can be written as y prime equal to y f divided by t, so then we are able to solve for it as long as we are able to compute the antiderivative of some function that I will mention later. Okay, so that is basically the idea, and how do we do it with that? So this is t y. Okay, so so one of the example is that I picked here is y prime equal to t over y, and so you may wonder what is the signal that we can classify whether it's a homogeneous Euler homogeneous equation or not. Okay, so one of the way is I usually do is that I will count the order of polynomial. So we know that so this is y over t, right? Y over t. So the order of the polynomial of the y variable here is 1, right? Because y to the power 1. And the order of t here is -1. So 1 plus -1 is 0. Okay. So somehow I can say it looks like the Euler homogeneous. And I use that test in the book. You can find the long theorem if you wish, if you want to, like the equation like m ty y prime plus n ty equal to 0, and n and m has the same homogeneous order, so then it's an Euler formula, but it's very hard to remember and it's not that valid. So I don't refer that way. I will choose the easier one to do with that. For example, for this one, if I want to test whether it's a Euler or homogeneous, I just pick the order of t. Here is 1. The y is 1 over y, right? So y to be -1. So 1 plus -1 is 0. So okay, it's vanished. So it looks like the Euler homogeneous. But how do we do that? So it's just, if you write it out again, it's 1 over y over t, right? Okay, so now you can consider y over t is a variable like v. Okay, so it's 1 over v, right? So clearly that f y prime equal to f of v, where f v equals 1 over v, right? So v is just y over t. So I just write it out like this. That's it. That's how you get the Euler homogeneous. How to classify whether an equation is an Euler homogeneous one. I will give you another example, which is very easy. For example, I have t square, maybe y square plus yt plus t square. Okay, so now I wonder whether it's a homogeneous equation or not, the Euler homogeneous equation or not. So what can I do? First, I have to move everything independent variable on the right hand side. I divided both sides by that. Y square, yt, t square. Divided by t square. Okay, and now I'm wondering whether it's a separable equation. Okay, and now I use my method that I test. So the order of y here is 2. Okay, good job. So we have 2. This is 1, 1. So the biggest order is 1 plus 1, right? This is 2. So also 2. And t squared. The power is 2, right? So it's 2. How about denominator? Denominator is t squared, 1 divided by t squared, right? So it's -2. 2 plus -2 is 0. Okay, there you go. Oh, it's Euler homogeneous equation, right? So, but specifically, if you want to be clear, it's going to be yt squared plus yt plus 1, right? So the function f here is just v squared plus v plus 1. Okay, so then f y prime equal to f of yt. Okay. That is the way that you can classify whether it's a Euler homogeneous or not. So let me give you another example. For example, I have y prime equal to ty plus y squared and then minus t, right? So whether it's a Euler homogeneous equation, can anyone type the answer or raise your hand or reaction? So if you react, so then it's an Euler homogeneous equation. If you don't, it's not. Any folks? Yes. Whether it's a homogeneous Euler homogeneous equation. Okay, good. 2 no, 2 vote for no. Good job. 3, 4, 5 no. Very good. And what's more? Okay. Yeah, so it seems that everybody choose not, it's not a homogeneous equation, Euler homogeneous equation. Yeah. So there are a bunch of ways that you can, yeah. I think the best way to study is to find out what is the most suitable for you guys. And I feel like this one is the most suitable for me because it's very easy to remember. So I choose the order of that, right? So this is what? So the order of 1, 1, right? So this is 2, this is 1, right? So they are different. We don't even have the denominator here. So it's very likely that it's a non-homogeneous equation because we are not able to transform it into the f of yt. Okay, so it's a non-homogeneous equation. Even if I put on here, we cannot have the homogeneous equation. For example, on that case, we have the order of 2, 2, and 1, and I divide by t squared. So I still have that term is the first negative 1 order, right? It's not 0 order because 1 over t is negative 1. So we are not able to transform it into the Euler homogeneous form. Okay, so now we go back to the equation, which is the most important one. How do we solve for that? So we know the trick, right? Why do we need the Euler homogeneous? Because we want to transform it into the separable form, a non-separable form to the separable form. We done the first step. Now the second step. Let's figure it out. Y prime, let me say y and t. Suppose that I have that Euler homogeneous. Okay. And what can I do from it? So I know that it's a function of f, right? So I let new variable v equal to y over t first. And what do I get? Y equal to v times t, right? Okay, so I will write everything with respect to y in terms of v and t. Okay, so I need to take the derivative of y prime. By the product rule, you can see that it's become v plus t v prime. And to flip on the left, you have t v prime plus v equal to f of v because we let y over t v. And okay, so I minus v both sides to get rid of v, and I b is dependent variable and t independent variable. It should be where it belongs to. So t to the right and v to the left. I have b prime fv minus v equal to 1 over t, right? Okay, now I have beautiful formula, right? We know what to do because it's separable. Okay, so now this is the crucial step right here, right? This is the crucial step. So just take the integral both sides, and you have dv fv minus v equal to the integral of 1 over t, right? And as you know, you can easily calculate that. It's just log of the absolute value of t plus some constant, right? So now the remaining thing is just how do we deal with that integral? So it depends on question to questions, problem to problems. We don't know yet. We don't even know whether the integral here exists, or we don't even know that whether the integral here is calculable, right? Or with just a number, it cannot write out explicitly. So we don't even know. But this is the best way that we can get, right? We make the non-separable equation into the separable equation by simply change of function, change of variable, v equal to y over t, as long as you write down in the Euler homogeneous equation, and we are able to get it. Okay, so now we have so we have 4 practice problems here. The plan is, again, this is a little bit hard, so I give you 4 minutes for that, and 4 minutes for that, 3 minutes for that. This is easy. 3 minutes for that, and this is a little bit hard, but it's not that hard. The last one is challenging. You can work on your home. If you need a solution, I will send it to you by email. If someone asks me, so I will send it to you by email. If we have time, I will fix that. If we don't have time, so let it to be your extra homework. If you want to do it, maybe you can spend 5 minutes for that. Okay, let's get started for the first one. You have 4 minutes for that. Okay, if some of you have the tablet or are able to write on the screen, you are welcome to come to my office, and I can help you to deal with some practice problem like this. You can write on the solution on the screen, and can I modify it? You can do it at the same time. It's very good. I will have office hour on Monday, Wednesday, and Friday from 1 to 1:50. If you cannot make it, you can send me an email so that I can arrange another suitable time for you. Okay, it's time. Let's do it together. First one, we have t squared y prime equal to 16 y squared plus yt plus 4t squared, and t is bigger or equal to 1. Right. So because t bigger than or equal to 1, so then we are okay to divide it both sides by t squared. We don't have to worry where t equal to 0, so then it's undefined if you divide something by 0. So you have y prime equal to 16y squared plus yt plus 4t squared divided by t squared. You have to make sure that on the left hand side you just have y prime. You don't have anything else, just y prime. And okay, so from here, how do we do with that? Again, you can use the test method that, so this is the fraction. We have numerator, denominator, right? So what is the order of the numerator, right? So we count the biggest one, right? This is 2, okay? This is 2, and this is 2. We have to count all of that. So every terms has the order of 2. Okay? And on the denominator, we have 2 also, negative 2. Okay, so t squared minus 1 divided by t squared. And then you take the first term plus first the order of numerator minus plus the order of denominator. We have 0. So it's a homogeneous Euler homogeneous equation. So if you want to simplify it, it's just y divided by t squared plus y over t and plus 4. Okay. So now you can easily recognize that the function fv here is just fv 16v squared plus v plus 4. Okay, so it works for that. So this is just a quadratic form, right? A quadratic function. And v we can let equal to y over t, right? So now you do what you need to do by writing y in terms of t and v, right? And we compute derivative of y equals to, by product rule, you have v plus t v prime, and you plug in, you have v plus t v prime equal to f of v, which is 16v squared plus v plus 4. And oh, I don't have much space left. Okay, so let's try to write it smaller. So I minus v both sides. I get rid of v. I have 16v squared plus 4. Okay, and I divided both sides by t, and I move the independent variable on the right and dependent variable on the left, right? So I have 16v squared plus 4 equal to okay, so I have maybe I should 1 over t, right? And then you just take the integral both sides. v prime 16v squared plus 4 equal to the integral of 1 over t, right? And maybe I will go over here. V prime 16v squared plus 4 equal 1 over t, and then we take the integral of v squared 16v squared plus 4 equal the integral of 1 over t, and now you just dv 16v squared plus 4 equal to the integral of 1 over t, right? And now you may wonder that what is the formula for the v squared plus some constant, because in this way we are not able to do the integrating factor. Actually, we can do that by using the complex solutions, and we can use the definition of complex solution to get the log of the complex solution, and it turns out to be some trigonometry function. But you are not in this step yet. So what can you do from now? Can anyone give me suggestions? How do we compute the integral on the left-hand side? No, it's not partial fraction because we are not able to factorize it, right? Because the solution here, 16b squared plus 4 is just equal to 0. If you want to solve it, b squared equals to -1/4, right? And b equals to plus or minus 1 2i, okay? And yeah, so if you do the do the partial fraction, you get the log of some complex number, and you don't study that yet. You have not studied that yet. So what is it? What can we use? What can we do? What can we do with that? Any suggestion, guys? Okay, use substitution is a good guess. What do you use? What do you want to substitute in? That's a good guess. Think about it. Okay, so maybe I don't see have anything, but let me remind you, or maybe you know how to do it. Anyone know the formula for this? What is the antiderivative of 1 plus x squared? So how do you know how to compute that? Okay, so if you don't remember, let me remind you. So you can use substitution like he said, like with x equal to tangent of theta. Let's see what's happened. So you know that tangent of square of theta plus 1 equal to what? X squared, right? Because you use substitution, and it's just 1 over cosine square of theta, right? Okay, so now we have to make sure to compute everything on x to theta. So that means you have to compute dx, tangent of theta, and the tangent of theta is sine of theta over cosine of theta, right? So now just use the what is called the quotient rule. You can use the quotient rule, or you can use the product rule. If you want to use product rule, you have to make sure cosine of -1. And you compute that, you get 1 over cosine square of theta, right? So what do we have here? We can rewritten the integral above here by just the 1 over x become 1 of tangent of square of theta, and dx become 1 over cosine square of theta d theta, right? So for example, I want to do the integral from a to b. Okay, let's say. So I have to make sure that x equal to a. So then what is theta? Theta equal to tangent, inverse function of tangent of a, right? Because x equal to a mean that tan of theta equal to a, and then you take the inverse function, is equal to b, so theta become tangent of -b, right? So if you plug in here, you have tangent of -a, tangent of b, inverse function of that. And this one, it just vanished. It's just become 1, right? So it's become the integral of tangent of -a, tangent of -b of 1 d theta. So it's become tangent of -b minus tangent of -a. Okay. So if you have the bounds, then you just have to plug in these number a and b. If you don't have the bound, it just becomes 1. If you don't have the bound, it just you just delete that. You have theta, right? And theta you can rewritten in terms of x, right? So it becomes tangent of negative x, right? So there you go. You know that the integral of 1 over plus 1 plus x squared equal to tangent of negative x, right? Right. Okay. So that is the way that you use substitution. Now, what is the relation between this term and 1 plus x squared term? So just have to be careful with that by simply just change the variable. We have 4v squared plus 4, right? So because, yeah, okay. Equal to the integral of 1t dt, okay. And maybe I write this 4v squared, I write it now into 2v squared plus 1. And then I pluck out 1 4 out, right? Okay, so now I can change a variable. I can let x equal to b 2v or whatever, just d2v. I can write it down in short. It's like 2v squared and plus 1, because I have number 2 here, so I have to divide it by 2. And now you can consider 2v is a new variable, and it's just 1/8 of tangent of negative 1. So inverse function, tangent, whatever is next, 2v, right? Okay, so there you go. You get it. So that is the left-hand side, right? What is about the right-hand side? Is equal to 1 log of absolute value of t plus some constant. So that is the implicit form for the function v, and you need to transform it into t and y, right? V equal to ty. Y equal to tv. Right. And if you want to transform it back, it just you can write it like this: tangent of negative 1 of 2 times y over t equal to log of t and plus some constant, and you move that into the left, 2y over t minus log of absolute value of t equal to some constant. So this is your implicit form. The solution for the implicit form is negative 1/8 of tangent. So have inverse function of tangent, or 2y over t minus log of absolute value of t. Okay. And what does it mean? Maybe I forget to mention it. What does it mean by implicit form? So meaning that you have a bunch of family of solution, but we read that is the sine of ty equals to some constant, right? So that is a solution for that question. Okay, so if you wonder how do we find the explicit form, it's okay to do that too. If you want to find the explicit form, so then you just need to solve for y, do the manipulation technique, just answer by manipulation, just plus L of t, and then you multiply by 8. So you have tangent of 2y over t equals AC plus 8 log of t, and then you take the tangent both sides, because tangent inverse, you take the tangent both sides, 1/2 equal to tangent some AC is just some new constant, C prime, I don't care what is that constant, 8 log of t, and then I multiply by t and divide it by 2, so you have t over 2 tangent of C prime plus 8 t. Okay, so that is the explicit form if you wonder for that equation. What do you need to remember? As you can see, we have some technique we need to do with maybe it will appear on the exams somehow is when you do separable equations, you always face with some kind of difficulty when you do computation like this. So remember to go home and remember to find out what is the formula for that, or at least know how to remember it. Know how to remember it. It's a good choice. We can use substitution, let x equal to tangent, then what we have. Okay. The second thing you need to remember is about the partial fraction. So this one cannot be cannot use the partial fraction technique, but something like this, 1 minus x squared, then we can, because we can factorize it. We can write it down in terms of 1 minus x multiplied by 1 plus x. And there we can do something like this. Okay, so they are different. Okay, but actually, if you study complex analysis, then they are the same. It's a different story. Okay, so now let's go to finish question 2. Okay, okay, question 2, you have 3 minutes again, and I'll solve that. Let's give it a try first. Question 2 here, y prime equal to y over t plus t. Okay, it's time. So let's do it together. So we have y prime equals to y plus t and divided by t. Okay, so this one, I believe you guys guess the solution if you account for that, because it's fairly simple. Okay, let me, maybe you are annoyed by that because I repeatedly try to repeat the method. I hope that all of you can get the correct solution and know how to do with that. So that's why I keep repeating my method. So, okay, so you can see that this is the fraction and the numerator has the first order, right? And the denominator has the first order, negative one order, the one divided by that. So it's gonna be 0 order, right? So then we can say that it's a, sorry. So, oh no. Sorry about that. Maybe I'll stop sharing now. I'll put back. No. Okay. Yeah. So. Okay. So we have y prime equal to f of y over t, right? So what is the function f here? The function f here is just v plus 1, right? It's a linear function. Because y prime equal to, if you separate that fraction into 2 fractions like this, it's equals y over t plus 1, and you consider y over t as a new function, it's a new variable. You can have y prime equals to v plus 1, which is yt. Okay, so now how do we solve that again? You write everything in y in terms of v, y equal to tv. That implies y prime equal to tv prime plus v, and then you plug in, you have tv prime plus v equal to v plus 1. Okay, from here you can just minus v both sides. You have tv prime equal to 1, and then you have v prime equal to 1 over t, right? And you take the integral both sides. You take the integral with respect to v, 1 over t, so you have v equal to log of t plus some constant. And okay, so sorry, this is dv, okay, dt. So you can say this is dv, and it's just the integral of v, just v equal to ln of t plus some constant, and you replace v in terms of t. In terms of y, you have y over t equal to log of t plus some constant, and y becomes t times log of absolute value of t plus ct. So that is how you get the solution for this. So this is an explicit form because you can write down y in terms of function of t. So that one is fairly simple. Let's try to do the last one. No, it's not the last one. If we have time, so then we'll do the last one. Okay, y prime equal t squared plus y squared divided by ty. I'm sorry that you don't have time. I don't let you do that by yourself, but you can try it at home. There are a bunch of practice problems if you need to practice more. Because we have to end the meeting at 12:10, so I need time to fix that question before the end of the meeting. Okay, so again, we use the test method. We have the second order. This is the first order. 1 plus 1 is 2. 2 minus 2 is 0. So this is Euler homogeneous. Okay, it can be written as y over t, right? So now we need to apply the function f. Okay, just a simple technique. Just separate the fraction here into 2 fractions, y squared over yt plus t squared over yt, right? And then you cancel out, you have simplified, just have yt plus ty, right? And from here, if you wonder how do we find the function f, just if you're familiar with that, you immediately get v plus 1 over v. Okay, If you are not familiar with that, you can write it down step by step. Y over T, V equals to Y over T, and then you write Y equal to TV, right? And then you plug in. So Y prime equal to TV prime plus V, right? You plug in, you have TV prime plus V equals Y divided by. So this term is just V, right? And that term, if you're not familiar with that, you will keep it T. And then Y equal to TV, right? And now it's just cancel out. The number T here is become V plus 1 over V. Okay. So now just need to solve for V. With minus both sides by V, you get just 1 over V, and then what do you need to do? Move independent variable on the left, dependent variable on the independent variable on the right, dependent variable on the left. So you have V prime equal 1 over T, and then you take the integral of V prime 1 over T, then you have V dV equal the integral 1 over T dt, and this is V squared over 2 equal to log of absolute value of T plus some constant. Okay, so now you have the implicit form. We have implicit form, sign, we call that sign, okay? V, this one is a Latino character, I guess. V squared divided by 2 minus log of T, right? And the solution is cosine of TV always equal to some constant, because we don't have the initial conditions, so we cannot find the quantity C. Okay, so that is the implicit form. So how about the explicit form? So explicit form can be found, okay, because the quadratic equation is kind of very easy to find. Just consider T is a constant, and then you consider V is a variable, and you solve for that equation. So if you do that, what you get is that T squared equal to 2 log of T plus 2C. Okay, I just let equal to C because 2C is just C, just some constant. Okay, so then you are able to let B equal to plus or minus square root of 2 log of absolute value of T plus C. Okay. Now, from now on, if you want to find whether it's plus or minus sign, you need to know the initial condition for it. That means you have to find V0. If you know V0, then you know what solution, what is the explicit form of the solution. Okay. Right. So I don't have much time, but if you are curious about the last one, I'll share you how to do it, and then we can start. But I don't finish the solution. T squared plus T 2Ty y prime equals 1. T squared plus 2Ty y prime equals to y squared. Okay. So now just it look a little bit complicated because we have a bunch of terms on the left hand side. We have y prime equal to y squared divided by t squared plus 2ty. Okay, so if maybe you have a better skill at recognizing the patterns, so then you can easily get that is equal to 1v squared plus 1 over v squared plus 2 over v. Okay, so if you have the good skills of recognizing patterns, so then it's easy to do. But if you don't, if you don't, so what is the best way for us to remember? You just need to let y equal to tv, okay, and do the same thing that I did. Write everything in terms of t and v. So we have on the left hand side we have t v prime plus v, right? On the right hand side we have t square v square divided by t square 2t square v, right? And then you cancel out t square, you have v square 1 plus v, right? And there you go, you get the idea, 2 plus v. So that is that's all about the
presentation meeting for today. If you have any questions, just I will stay here and answer your questions. If not, you are allowed to go. Have a good day and see you on next Thursday. Goodbye.